This is a talk I have looked forward to for, I think, almost 2 years. I've looked forward to be able to stand here and talk about this. It's a... sometimes we think we live in an age where everything takes about 2 weeks. So you make a startup, 2 weeks, you expand to 100 million users, another couple of weeks, then you sell out, you get $1 billion, another couple of weeks. I would love that, but I live in a different world, and it's a world where sometimes things take years, actually, to materialize. And in this world, we had what I would call the Big Bang model of database evolution. Internally, we used the term the database shop. So people would ask, is the database shop open? And the answer would usually be, no, it's not. And from time to time, there would come a big release, a big version, big development project, where we would open the database shop. So we would decide, in this release, we are going to change the database. And you can hear the capital letters. It was a big deal. And just like the Prince of Wales has a bunch of other titles, Count of this, Duke of that, I have a bunch of other titles. And one of them is Chief of Database, and has been since I started in SuperOffice, which is a long time ago. Now, opening the database shop would mean, in particular, making sure that the upgrade code was upgraded and present. Yes? A little bit more down. Like that?
Yeah, perfect, thank you.
Okay. And this code is something that I would write, and I would have to rewrite it, part of it at least, for every database upgrade. C++ code buried deep within the Windows client stack. Dark secrets. And this is the code that would both do the structure update itself, but always there is also a need to do something, to populate new fields with data derived from what is already there, or clean up something, or move something from A to B, or whatever. And so in our development projects, we would do all of that. Typically, I would have to modify somewhere between 20 and 30 files to start to open the database shop. And then, as the development cycle proceeded, we would decide, we need another change to the database. So we would change the model, regenerate the code, and we would have to throw away all our test databases and start over from the last official version, because one thing we didn't do was to upgrade in many small jumps. It was always, you have an official version, then you have the next official version. Customer service, or rather eJournal, when it was still called eJournal, was better than that. They did database changes fairly often, and they could take any database at any point and upgrade it to the current latest. But of course, when they were bought up by SuperOffice, and we have structured R&D department, all of that went away. On the other hand, they got some benefits. Now, and as the release draws near, since setting up the database shop is so expensive, you get a certain sense of panic. Have we included everything? Are there any features that we think we are going to make within the next 6 months that will need database changes? If so, quickly decide the database now. And I think without exception, we never got it right. So when you're trying to define the database changes for a feature that you haven't fully defined and designed, you're not going to be able to do it. In between the big updates, excuse me, in between the upgrades, we did updates. And an update is priming data, the static data that we put into an empty database, because a really empty database doesn't work. You have to have some stuff in it. You have to have the definitions for the reports. You have to have the zip codes. You have to have the license information. You have to have the standard lists. You have to have the SuperOffice card. Very important. That keeps changing. So we would issue updates, and updates would only change the data, not the structure. And of course, some people would install the update, and some wouldn't. Online said, this is too hard, we're not doing this. Forget about the updates, we're not doing that. And so when the time comes for the next upgrade, we don't really know what state the database is in. Has it been updated from SR1 to 3 to 4? Or from SR1 to 2 to 4, skipping 3, because you could do that. And we were trying to educate people, what's an upgrade, what's an update, can you do it twice? No, you can't. Now, in spite of all of this negative PR that I'm giving this process, this actually worked pretty well. And it worked because the whole of R&D, the whole of the product, was running on a 1 year or 18 months development cycle. We would develop for close to a year, spend some months tearing our hair out, trying to get the bugs out. Then we would issue a release, and customers would upgrade, and it would take 2 to 3 years to upgrade the whole customer base from one major version to the next. And of course, as long as you're doing that, having database changes every 18 months is fine. You don't actually need anything else. But times change, and this process doesn't really work anymore. R&D is now on a 3-week release cycle. Every 3 weeks, there's a new version in online. And of course, it's hard to tell the developers that you're supposed to release new features every 3 weeks, but you can only have database changes once a year. Senseless. And so we've been thinking about how to make the database more flexible. And we've been thinking for several years, and I and Ludwig have been programming since Easter. And now we're almost done. And what I'm going to talk about is how far we have come and what we are going to release to online in less than 3 weeks from now. It's going to hit the on-site market in version 8.1, and that's going to be, am I allowed to say that? Yes? Asking the wrong people. That's going to be early next year. So Q1, probably more the beginning of Q1 than the end of Q1, I hope. Then it's going to hit you. It's not the end. At the end of the talk, I'm going to say a few things about what I think the future will be and how we foresee it evolving. But what you're here now is what we're going to release quite soon. You will get it as an alpha again in a couple of weeks. I'm sure Tony is looking forward to upgrading all the tools, so they are ready for that. Yes. Sincere joy. He's happy. So you will see what's coming. And as always, when we do something major, we have to go back to the requirements. What's the point? Why do we want to change our database process? One of the requirements is that each sprint team owns its database changes as a natural part of the feature development. So if we have one team working on dashboards, another team working on the new inbox that Erik announced, a third team working on some other new feature, let's say budgets. Each of those teams has requirements for the database. And the best process is one where they can take ownership of those changes without having to coordinate too much with what all the other teams are doing. Like, we're going to release the database in 4 weeks. Who has something they want to be in there? Is the wrong way of doing it. It needs to be pushed the other way. We need to add 2 fields to the database. Let's do it. And of course, these teams have independent and overlapping timelines. Partners are simply another kind of team in this way of viewing the world. And in the future, runtime changes through the user interface that's available to customers, to users, are going to be another source of changes to the database, because customers also want to change the database. They want user-defined fields. They want additional tables. They want to change stuff. One of the requirements we put in was that once you have upgraded, you can't roll back. There's this pattern called compensating transactions, where you can make a change and then you can undo it. But think of what it would mean to implement this pattern in a world where you have multiple independent sources of changes. You have change A, change B, change C. Maybe they're dependent. Someone wants to roll back B. What do you do? It's just too complicated. So that was one of our requirements. We also wanted to end up in a world where structural changes, priming data, and the custom code that does the magic in each upgrade should be close together, like in the same file or same folder, or at least somehow closely related, so it's easy to see that this change to the database consists of these parts, and this is what it does. No hidden stuff. Today, we're in the lucky situation that if you, in a priming data file, just refer to the to the function right table, I can't quite remember, one of those. If you just have an empty section with a table name in it, suddenly data appears by magic, even though there's nothing in the file, because it's hard-coded in the code that reads the files. Because at one point, we needed to do a cleanup, and that was the way to trigger it. And we had several thousand lines of code sitting there, reacting to things in a spooky fashion. We also had some I would say, sanity requirements, such as a change that would mean rewriting the database layers in NetServer, Windows Client, and CS would be just too big. Eating elephants is fine, one piece at a time. Trying to eat 3 elephants in one go would be just, no, don't do it. And similarly, we didn't want to totally rewrite our code generation templates and the code generated by those templates. Now, database changes, as you will see further on, will be expressed as, at least initially, as .NET compiled assemblies, DLLs. And that means we have a requirement that once you have made one of those, 5 years from now, it should still be useful. It should still be, the code that we have 5 years from now should still be able to load and execute the code in that old assembly, which means once we define some interfaces, we can't change them. We can add new ones. We cannot change them. And we should try to keep the dependencies at a minimum. The evolution of the way we describe the database is very slow. So NetServer code changes all the time. Database is going to change quite often. The way we describe changes to the database is not going to change as often. And when you have different rates of evolution, that means you cannot have hard version dependencies or version numbers that keep changing all the time. It should be possible to fairly easily express how you add, modify, and delete tables, fields. As said before, you should have all the parts of a database upgrade should be kept close together. There should be a clear flow for the developers. How do you do this? And obviously, we need to make an equivalent toolset available to partners. I'm not saying the same toolset, because the toolset we use internally has some features that makes it less useful for you. One of them is integration with our TFS, source control system. So it automatically checks out files when they are changed. It might do things like update project files in our solutions. You don't want that. But you do need a toolset that does the equivalent work for you. Now, the question is, do we make this ourselves or do we buy it? Because there are lots of tools, very good tools, to administer database schema changes. Lots of tools. You have, some of them are part of a bigger system, like the Entity Framework from Microsoft. You have Redgate. They have a huge selection of database tools, maybe too many even. I hope I'm not insulting someone now. But there is one underlying assumption which is so obvious that you don't actually see it. And that is, all of these tools assume you have a database schema, one database schema, that you know all of your database schema. We don't. That's a fundamental difference. Because we have multiple sources of changes. The developers in SuperOffice R&D know what the SuperOffice database that we design looks like. You know what your changes are supposed to look like because you own them. And the customers know what their changes are supposed to look like. But there's no one who knows ahead of time the sum of all these changes, which means there is no database schema I could feed into one of these tools and tell the tool, this is the state I want to reach. Now you fix it so the database is upgraded to this state. I don't know what the outcome is because it all depends. Depends on what we have done, what you have done, what the customers have done. And that means the first and only place you know what the database schema actually is when you upgrade one particular customer with one unique history to one particular version. And that pretty much excludes all the tools on the market. Oops. So we had to make something ourselves. And as you can hear, it's all about specifying changes. We cannot know the desired final state. I know what fields I want to have in the contact table, but I don't know which ones you will put there. So what I can specify is I want another field, I want another table. So that's what we do. We specify changes. And that's one of the fundamentals of this system. All the time it works with what is it you want to change. The system will integrate all the changes into something we call the database model, which is the replacement for the old dictionary tables, conceptual table, conceptual field, physical table, physical field. Those are going away. They have served us well. They are being retired. We're replacing that with a new technology. Fundamentally, it's about the same thing. It describes what the database looks like because it's very useful to have such a description in the database. That's the database model. Physical database also gets the changes applied to it. And unless something goes badly wrong, the database model, the physical database, will be in sync. whenever developers decide to generate code, the same thing happens. All known changes are integrated into a current database model. That model is then what we generate code from. That is the code we submit to TFS. That is the code we build and release as part of NetServer. Now, of course, for this to work, that code has to tolerate that the database looks different, certainly in the sense that there is more in the database. That's nothing new. We're already there. You can use extra fields in service to add fields to the contact table in SuperOffice, and it works. NetServer doesn't break, Windows Client doesn't break. One of the consequences of this is the question, which version of the database are you on, becomes meaningless. There is no single answer. What we can say is you have the inbox feature up to level 2. You have the dashboard feature up to level 3. You have advisor something module thingy up to level 1. And you have user-defined fields version 6. That we can tell you. And we can tell you who made what change. But there is no longer any single database version number that has any kind of meaning. And it doesn't matter because we don't need it. What we need is what's actually in the database and how far have we come for each feature. There's also no concept of one particular organization owning a table. Now, of course, being the owner of SuperOffice database schemas, I can put in an extra rule saying that you cannot delete fields from the contact table that I have put in there. I think that's a sensible rule to have. I'm sure you can program around it if you put your minds to it. If you do that, I'll tell Margrethe. You know what that means. But apart from that, if the dashboard people need to add a field to associate, such as my favorite dashboard, if you need to add a field to the appointment table, that's fine. You should think a little bit about, is that a good thing to do? But the system itself is designed to allow you to do that. The unit of change, the thing that developers work with, is something we have decided to call a dictionary step. And the dictionary step has a name, it has a number, it also has a state, an enum saying, is this in development or released? We don't have to think too much about that now. The important things are the name and the number. And the name is simply a namespace for a sequence of numbers. And every dictionary name starts with step 1 and goes 1, 2, 3, 4, 5, and up. The dictionary step is what contains your specifications of what do you want to change. What structural changes do you want to make? What static data do you want to import? What custom code do you want to run? And what you will see in the database model and the physical database is simply the result of applying all the dictionary steps in order. So any dictionary step may contribute to any table or field. And initially, we are saying that dictionary steps are something you define by writing code. You compile that into an assembly. The last sentence, once committed to source control, dictionary step is frozen, cannot be modified or recalled. That's how the world is for us. And the reason for that is that once it's in source control, it goes into the build system, it's deployed, test databases start getting upgraded, and the whole ball starts rolling. You are free to modify the statement into once released into the wild. A dictionary step is frozen and cannot be modified. But that's the outer limit. Dictionary step can only be applied once. So how does this work in practice? Well, we've had a design meeting. Now we need a new table. You still need to think through your database design. The main reason for that is code and database are different. When you release code, you are replacing all the code with your new code. Which means if it turns out you made a mistake, you can either bring the old code back by simply throwing away the new and replacing it with the old, or you can make an even better version and you're throwing away your new code and you are replacing it with even newer and better code. And it doesn't matter that some version of the code is now thrown away forever. You can't do that with a database. You can't say, oh, shouldn't have changed the table that way, let's throw it away. Now this is the structure it should have. Because you are losing data. So you still need to think through your database design. Certainly, internally, we are going to practice that. I'm going to retain my hat and feathers as chief of database. And people like Anders will have to get their database changes approved by a committee or by me or whoever. We'll invent a process that works. But it's going to be more than one developer deciding on Friday afternoon that, we need 3 new fields, bang, in with them. You create a new dictionary step. And if it's a first change, is this a new name? Or are we just continuing? Is this a new feature? When the dashboard people are going to create their first tables, they're going to start a new name series called dashboard. We already have a name series called SuperOffice, which is the base database. It's the 8.0 model, plus the changes we need to make it into an 8.1 model, like just getting everything running. But after that, each team or each feature is going to have their own namespace so that they can evolve in the tempo that suits them. Then you write the changes. I'll show you examples of all this. Then you build and run the modeling toolchain, which is going to pull together all the known changes, generate the model. You can generate code from that. You get a new net server. You build that. You take a backup of your test database. You use our upgrade system, DbSetup, or it's whatever comes after DbSetup. Do the upgrade. And the system is going to detect that, here we have a dictionary step called dashboard. It's step 1. Do we have that in the database? No, we do not. Okay? In with it. You test your code. And if you're satisfied, that's fine. Maybe you're not satisfied. Maybe you discover, the field should have been a little bit different. We actually need a float here, not an int, and the strings should have been longer. And it's probably a good idea to include an index. So you do that, redo the whole thing. Once you're done, you submit it. And in your case, whether you want to run a tight ship and say, submission to your source control system is the last thing you can do with the dictionary step because it goes into your build and test deploy and automatic test and blah, 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 and is thus actually committed to following the build pipeline all the way out to the customer. Or if you have a, shall we say, more flexible process where it doesn't matter too much, and you can go back and you don't mind throwing away your halfway upgraded test databases, that's up to you. In our system, committing it to TFS, we'll pick it up. It's going to get deployed into our development online system. And if you dare upgrade a customer to that file set, the upgrade will run and the database will be upgraded. And you can't go back. You can only go forward. So if you decide that it should have been different, you create another dictionary step. And then when the database gets upgraded with that step, it becomes what you wanted. And this means we can take any database, which is in any state, from totally blank to yesterday's latest, and we can upgrade it to today's latest with the same code. So that means as we go forward and release version 8.1, 8.2, 8.3, you will be able to take a customer who's on 8.0 directly to 8.3 because the path is there. We never throw anything away. We are going to accumulate a big pile of these dictionary steps, which of course means the code that does the upgrade has to be fast. That's not a problem unless you do something very slow in your custom code. And so we will be able to take any database and upgrade it. But that also means you can never go back and you cannot break the chain. Or you can't consolidate because that would mean saying that all these intermediate states are now invalid and dead ends. We can't do anything with them. We don't want to do that. Maybe in 5 years, we have so many changes accumulated that we say, okay, folks, version 10 is a consolidation point, so you have one branch of the code that takes up to 10, and then we start all over from then on. I don't know. Maybe. I was talking about compensating transactions rolling back. Now, during an upgrade, things might break, and especially custom code might break, but also bad priming data might break. And there's no way to make the database do a rollback for us. I wish there were, but you can't. In SQL Server, you can actually have a transaction around a create table, but there are some fairly strict limitations on what you can do. And in the other databases, say Oracle, any data definition language statement, such as create or alter, auto-commits immediately, and that's it. There is no rollback. So it means once we have started to upgrade a database, if it fails, we're stuck in some kind of in-between state, and we have no way of getting ourselves out of that state. You have to do a restore. We could, of course, try to create code that meticulously tracks every change made to the database and is able to generate a rollback thing. Think of the nightmare that would be to test and try to prove that this works in every unexpected crash case. I'm not going to try. And that means in online, when we upgrade customers, we take a backup, we do the upgrade. If it works, we throw away the backup. If it doesn't, we roll back, and we keep the customer on the old file set. So how do we change the database? How do we do it? There are several alternative languages you can use. The first and obvious language is SQL. You can say create table. You can say alter table. But it turns out the way to say this varies between databases. And it varies just enough to be absolutely irritating. So, building some kind of SQL dialect that we then translate into something else, yeah, okay, fine, we can do that. But we would then want to make an editor that would help you a bit, like Sverre did with CRM script. But we have this wonderful language called C#, which actually is good enough to be used for this. So instead, we're going to do it as C# code, which you will see in a moment. And executing that code creates a data structure, which is a list of change commands. Remember, we are specifying changes, not outcomes. We are specifying changes. So executing that code will result in a simple list with objects like add table. And then the object contains information about the table to be added. And that would include a list of add fields with information about each field. So what we are going to do is to write the code that, when executed, results in this data structure. And it looks like this. At the top level, dictionary step consists of 3 things: structural changes, priming data, static data, custom priming code. So to create a dictionary step, you declare a class which inherits from the class dictionary step, and you override whatever of these methods you want. Suppose you just want to update your static priming data. SuperOffice in Denmark has a new managing director. You know, these things happen. So we want to update the priming data with Pernilla's name and details. We would create a dictionary step that overrides impfar names. We would create an impfar. Are you familiar with the format of the impfars? It's the same we have today. Tab separated with brackets saying which table. So you would create an impfar with a few records in it, and we would override just the impfar names method and return the name of that file. We would not override custom priming. We would not override structure, because there are no structural changes. What we have here is what we used to call an update. On the other hand, it might be the dashboard, let's say the inbox project. Let's say that they create new tables, but they don't have any static data to prime. They would override the structure method, specify their structural changes there, leave the rest alone. That would be a simple upgrade in the old terms. In the new terms, it doesn't really matter. You have a database which may be blank or may have some content in it. You give it all the dictionary assemblies with all the dictionary steps in it. We will ensure that each step is applied exactly once, and that steps inside one namespace are applied in order 1, 2, 3, 4, 5. And if they are dependent on each other, we'll try to resolve those dependencies. And if you have circular dependencies, then you have made an error, and you will be notified, and the upgrade will stop. Impfar names, as you saw, here it just returns a list of names, and presumably that's what 99 out of 100 implementations are going to do. But bitter experience tells us that sometimes we need to maybe investigate what's in the database before we decide to put in this file or that file. And I'm not talking about languages, I'm talking about more fundamental differences. So we made it a method so it's possible to write code there. And custom priming, we'll come back to that. There's a kind of very thin database layer available to make it easy to interact with the database. When the structure method is executed, you get this command list. And the command list is one of the key data structures in this whole thing. It's not a data structure you will see initially, but once we make database changes possible through net server service agents, that's probably what's going to be the structure passed in. When we apply changes, the command list, the structural changes in the form of a command list are applied to the database model. So we fetch the database model from the database. We apply the commands to it, which means we update the database model as the commands tell us to do. And then we can apply the same command list to the database to upgrade the physical database. We could also apply the command list to an export file during an export operation. So applying a command list during an export means simply writing it out to the file in a way that's readable. Similarly, we can get command lists from dictionary step classes being executed, but we can also get command lists from other sources, like reverse engineering the old dictionary tables, or reading from a file. So finally, this is how you create a couple of tables and add some fields to them. It works. Thank you. Oh. Is this better? Yep. Okay. So we have our class. The name of the class doesn't really matter. What matters is the dictionary attribute on top, which says this is a dictionary step. And it's called movie, and it's step 1. And we are overriding the structure method. And inside the structure method, we can say a few things. We can say create table, modify table, delete table, and not much else. And this initial clause is the start of a potentially very long set of function calls chained together. And each of them does something. So if you start with create table, you're only allowed to say add string or add whatever. If you start with modify table, and you do dot and control space to get the IntelliSense, you will see that there you have both the add but also modify field methods available. Each of these methods has a few mandatory parameters, so you must give the field a name, you must give it a description, and since it is a string, you must give it a maximum length. And then there's a whole pile of optional parameters which you can address by name. As I said, C# is a wonderful language for this kind of thing because you can specify a dozen options, but usually the default values will be fine and you don't have to have the clutter of saying true, 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 false, false, true, false, 0, blank, true, or whatever it would be. So in this case, I'm adding a string, and I'm saying it's not null. I'm adding another string, and that's not null false, which would be the default. So I actually don't have to say that. I put it in just to show I can. I'm adding a bool, and I'm giving it a default value. And because the method is add bool, this is a strongly typed parameter. So it actually takes a Boolean default value. And add double, and here the default value is 4.5. And if I write 4.5 here, I'll get a compile error. And finally, semicolon, that's the end of the create table. And here I'm creating another table, and I'm putting on some indexes. And if you want to index one field only, you can do it here directly when declaring the field. If you want to index multiple fields, you do an add index and then just list the fields. Similarly, if you want to remove an index, you list the fields. The name of the index is not something you're interested in anyway. And it's okay to ask the system to remove an index without knowing whether it's there. We'll find out. If it's there, we'll take it away. To change a table, we're on movie, step 2. We're modifying the table, adding 3 new strings. I'm also adding the registered and last updated fields because I forgot them the first time. Stupid me. The review should have caught that. So this is an example of a macro that adds more than one field. I should go back and note that nowhere do you see the primary key field being added. It's kind of obvious and given. So unless you actually need the primary key field to somehow have a non-default name or whatever, you don't mention it. If we see create table followed by something that is not specifically a primary key, then we say, oh, you want the standard primary key, right? Bang, you get it.
You can add the extra updated and registered columns as
No, those you have to remember yourself. And the reason for that is some people have, on a few occasions, said, I don't want these columns in my table. In many cases, they turned out to regret that choice, but I still believe in a reasonable number of freedom, reasonable amount of freedom of choice. And here you see add unique index. What you don't see is that you could have said comma, another field, comma, another field. Yeah. So that's how you create. In this case, you create an index that could have been created in the original add, but we forgot to do that, so we're doing it now. And it happens to be unique. There's another function, add index, that adds non-unique indexes. Yes?
Can you add on-delete cascade and such things as well?
No, you cannot. And the reason is...
What was the question?
Yeah, the question was, can you add things, can you specify things like delete cascade or check foreign keys, check relations and such? And the answer is no, mostly because we don't do that. We still don't declare our relations. We will be declaring our primary keys as primary keys. If you think that is very important, you can come talk to me afterwards, but so far we're not doing that.
What about the count field, updated count? Is it still there?
It's still there. I'm thinking about removing it because it's kind of left over. It used to be our emergency exit.
Like the registered and updated.
Yeah.
It's a special.
Yeah.
Name.
Yeah. So this method will actually add all the 5 fields, the registered, registered by, updated by, and updated count. And updated count is the most misleading field name we've ever had because it has never been used for that purpose. Not once.
And it's too small. Also.
And it's a short, so it's useless for other stuff. Yes. It's left over. I think we should remove it. Yes.
Did you say that there's no reference type of field like you have in service? Like an add? Yeah, okay.
Like this.
Yeah.
This is to us, a strongly typed relation. But we're not telling the database about it. You may agree or disagree with that. We can have that as a discussion afterwards. But to us, it is a strongly typed relation. And if, for instance, the movie table is defined in a different dictionary step, which is part of the same upgrade, we will make sure that that step runs before this step, because we look at the relations, the dependencies.
Well, you probably come to that, but I haven't understood. Is database model something that you can find in the database as a kind of replacement to the physical table? So?
Yes and no. You can find it. You probably won't be able to read it, or you cannot read it directly in Management Console.
Okay. The next question, which you probably then will come to, is how do we know? Are you changing the concept of sequence as well?
No.
How do we know which IDs belongs to a sequence?
That's because the sequence table is getting 2 new fields: table ID, or table number, and table name. So you will be select asterisk from sequence, and you will be seeing the table names, table numbers, next ID. Priming data. I have to make sure I don't go too much over time. Static. Said all that. People might skip updates. That's not happening anymore, because the priming data will be bound to a step, and the files will not be reusable. So the imp files belonging to one step will contain the changes needed by that step. We're going to stop doing truncate table, reload everything. So if there's a dashboard step that introduces 3 new preferences, they're going to have an imp file with a prefdesk section with 3 rows. Nothing else. And Your responsibility is to tell us the name of your imp files. And then we will look in the proper places. We will look in a language subdirectory first. We'll look up the language of the database. We'll see if you have a language version of the file. If not, we'll look in the root directory for that step. And we'll publish some guidelines on how to structure the folder names. And if it doesn't find, you will get an error message that lists all the places it has looked and exactly what it has looked for, so you can actually have a chance to debug it. Now, initially, ServerSetup and DbSetup are still with us, and the way to set up a new database or do an upgrade is still the same. It goes through the Windows client CD, and it's still ServerSetup that is the only program that knows where to copy what files. I think we'll scrap both of them and create something new and better. But that's for next year. So initially, it's the same thing. If you already have a valid file structure, you can use DbSetup to do an upgrade, which is what you will be doing as part of your development. The upgrade itself is a one-line managed C# call, so you could create your own command line utility that does the upgrade. If you want to, that's fine. Now, it's a fact that structural changes plus static data is not always enough. So you may want to talk to the database, read from the database, write to the database to change the data. Please don't do create table on your own because you don't know how to do it. We do. We know all about the prefixes and the all caps mess on Oracle and quoting and all of that stuff. But changing the data, you may need to do that. And we thought quite long and hard about how to do that. Should we make it so that you could use NetServer to do this? Because NetServer has a database access layer, which is fairly nice. But NetServer is built on the premise that there is a database there that can be used. And this is precisely the situation where that is not yet the case. For instance, when I am upgrading from blank, that's the same as a new installation, by the way, but it's an upgrade. There is no associate table, there's no credentials table, there's no license. How should I make NetServer work? So we ended up with something else. In the CustomPriming method, you have access to a kind of lightweight database layer, which I think is fairly good and sufficient. And I think it's sufficient because it's enough for us. There's enough functionality in there that we can build an 8.1 database either as an upgrade or from scratch, handling all the special cases we have accumulated through all the SRs. And we are still able to do it without doing anything that you can't do. And this says most of it. So you have an execute SQL method. What you send to it is your SQL text. This gets passed to the database with a few exceptions. Everything inside curly braces triggers some parsing. If you have a single word inside curly braces, that means a table name. So it's going to get prefixed and quoted. If you have word.word, you mean a field name. So we'll quote that. If you have this construction, it means a parameter. We are going to generate a database parameter because we are using parameterized queries to guard against SQL injection. SQL injection attacks through a database upgrade would be an absolutely horrible security risk. We don't want that to happen. So don't hardcode parameters, use this syntax. And then, as a second optional parameter to the execute SQL, you pass in a class that must expose either a property or a variable that has the same name that you have referred there, and that must have a compatible type. So in this case, movie registered is the datetime field in the database, so I'm passing in a datetime variable. And again, C# comes to the rescue with the elegant way you can declare an anonymous class directly in the statement. So I'm declaring a class without having to call it anything, and I'm saying it has a variable called now, and I'm initializing it to this, so that makes this a datetime. I could have had a class declared in the ordinary manner, class blah, 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 with lots of fields and properties in it, and passed that in. That's fine. We don't care. We are going to reflect over the object you give us, and we are going to look for a field or variable called this name. If we find it, we're happy. If we don't, we're not happy. If you need to reuse it half a dozen times, it's fine. You can say var my class equals this clause, and then you pass in that variable in each statement. That's fine. That's functionality that C# gives us. There is another execute method which returns a data table. That's what you use to fetch stuff. Returning a data table means you get a disconnected, buffered result set. And we have to do it that way because we only have one connection to the database, and we have no way of creating other connections. Because that connection might have been created by a program that, for instance, impersonated an Active Directory user and used integrated security to log onto the database. That is a valid configuration set up in a NetServer config file. If that is the case, then 16 levels down and away, I am unable to open another connection with the same credentials because I don't have access to them. So we have just one connection, which means logic of the kind of fetch all appointments and then do something to them is best avoided, because you'll end up with a huge buffer. Tooling for partners. You already have tools supplied by Tony that generate NetServer classes for your partner tables. The old COM-based dictionary SDK is going away. It's not part of the next release, and it won't work, the old one. So what you do instead is you do all the stuff that I showed you, and then you fire up Tony's tool version 8.1, point it at the database, and it's going to read stuff from there, recognize your tables in there, generate code for that. So it's going to be much the same as you have today. Now, what about an interactive database change tool? Something where you can sit and, design tables, add a couple of fields, come back tomorrow, add a few new fields, and so on. It's perfectly feasible to create such a tool. I strongly believe that the design has taken the possibility of such a tool into account. However, I don't think I will be the one to make such a tool. But I do have opinions on how it would work. Its state data model would be the database model in the database, or your own version of it that you store somewhere. That describes the database as it is published now. That's the known state of the database. Its change data model, the stuff you work on in the user interface, I want to add this table with these fields, that would be the command list. And the command list is defined in a public interface in a DLL that's part of our standard distribution. If the tool has an apply button, that would instantiate the database management class and call the auto upgrade, giving it the command list. And that would apply that method, then does whatever the dictionary step says should be done to the physical database, to the database model. Or if you want more fine-grained control, there is a physical database applicator class which does exactly what the name says. It applies a change list to a physical database. There's another class that applies a change list to a database model. There is another class that applies a change list to other things. All of these are, of course, available. So public class, blah, blah. You're free to call them. Save in such a tool would take the command list, persist it, and the way we have persisted the database model, because you asked, what's the database model? Can you read it? Well, yes and no. The database model is a set of C# object structures. Again, it's a list of tables, and each table has a list of fields and a list of indexes, and each table and field has a bunch of properties that describe that thing. What we do is we use the Newtonsoft JSON converter, so we just take the whole structure and say, persist this to JSON, keeping object references intact. Then that gives us a big string, about 3.5 megabytes. So we zip it, and then we base 64 encode it, and then we store that in the database. You can undo that. Again, the code that does that is part of an assembly that you are free to call. There's a nice method in database management called read database model, which does exactly that. Or if you have your own sources, then the other parts, the simply taking one of these structures and de-zipping, de-JSONing it, there's an extension method that does that. So you can actually apply that extension method, you get the database model. And perhaps most interesting, if you had an export button in such a tool, you would use maybe a T4 template, which you can get from me for free, or you could encode your own way, but you would then generate some... went the wrong way. How likely are you to recommend? Not very, if you keep bugging me. Go away. So if you had an export button, you could generate this from your tool. And you would then have a redistributable unit, something you compile, drop into a customer installation, say upgrade, and bang, your changes have been applied to the customer database.
So it doesn't need to be compiled?
No, it does. What you give us is this in a compiled version.
In a compiled?
Yeah.
But you can also do that in the tool if you like.
Yeah. So, yeah, because the C# compiler is available in the C# runtime. So you could actually emit an assembly saying, this is it. So if anyone wants to make such a tool, that would be very nice of you. First one to do it gets rich, right? Or at least gets 1 million points on DevNet. Don't you think so, Tommy? At least 1,000. Yeah. So those are my ideas for such a tool. I cannot honestly go to Guttorm and ask for the time to do it because we internally in SuperOffice don't really need that tool, I think. Time will show, but it's probably something you have to do. Okay, we are approaching our time limit. I think there's 7 minutes left. There's one thing I would like to show you, and that is priming data code, a more comprehensive example.
Question, Marek.
Yes.
Have you thought about doing the same concept for additional fields?
Yeah, the other ways we have of changing the database. So today we have this way of changing the database. We have the service product with extra tables, extra fields, and we have user-defined fields in sales, which are a kind of quasi database change because, as you well know, there's a fixed table structure underneath, but the way we use it changes. My ambition is to eat both of those other systems. And in practice, that would mean making this interactive change tool as part of either the service or the sales client. And my bet is that it would be the sales client, obviously, because we want to melt them together, and sales client is the technology stack we want to go on with. So when we decide to do that, we'll end up with an interactive database editor as part of our admin. And it's going to do the things I outlined. That's the data structures it's going to operate on. That's the functionality it's going to have. And my ambition is that this should replace both the systems. So both what you have in service and UDEF fields in sales should both be replaced by this single unified way of changing the database at runtime.
We use prog IDs a lot. Could it be an idea to implement prog IDs in this scheme now, already? So that you want to keep that if you do additional fields.
Yes, sure. And the extra tables mechanism has its own dictionary with lots of funny checkboxes and properties on it. And extra things like what's the header of this field going to be in Swahili. Remember what I said, our experience is that if we try to design the database for a feature that hasn't been thought through, we will make the wrong decisions in the database design. So I was very tempted to add to the database model things that would make it usable for these future extensions. And I thought, hold on, I'm not going to do that. Because when this happens, we are going to probably rethink both UDEF and extra fields. How are they defined? How are they designed? How do you specify their user interface properties? How do you specify other things? And with the new privacy laws, you'd probably want a bit saying this field contains privacy-sensitive information as defined by the laws. I can't predict all of this. And so I'm not going to do any of it. So my database model, as it is today, is what we need. Let me just load this in the meantime. Yes, go offline, that's fine. So the database model as it is today defines what is needed to make NetServer and our other clients run with today's definitions and with the means and needs they have today. And what happens when we decide to add functionality is we're going to have to change this. We're going to have to extend it. So that's going to be one of the cases where the description of the database changes. And that's why you see a namespace called V1 over there. See it down there? So the database model contains, for instance, a table model. And the table model contains predictable stuff like name, description, flags, lots of other things. And it used to be that we had this internal model, and then we had the deployed database dictionary in the dictionary tables. And that was just a subset. That's not the case anymore. What you find in the database model, in the customer database, is the full description. Everything is there. There is no loss of information, and that's by design. So what happens when we decide to change this? I can't just simply change it because I would break backwards compatibility. So what I'll do is I'm going to keep this forever. And I'm going to make a new namespace, .v2. And I'm going to make a new table model, v2 table model, that inherits from V1 table model, or simply copies it. That depends on what kind of changes we are going to do. And the V2 table model is going to have a constructor that takes a V1 table model and does the conversion. And so the things that you define now in V1 are going to keep working forever, because in 5 years' time, when we are up to V3 maybe, we're still going to have V1 unchanged, original, compatible, linkable in the assemblies. That's why we have separate assembly with just the interfaces and just the models in it. And we're going to read your V1 model, and we're going to runtime reinterpret it as V2 and reinterpret that as V3, and then push that into our implementations and work with that. So we have an upgrade path here. And that's why I can say that I have put in only what we need now. When we decide to, for instance, absorb the CS extra table system, there's going to be a V2 guaranteed with all the extra information needed for those tables. Maybe as a separate object that will hang on some of those tables, not all the others. That remains to be designed. So changes will happen, but they will happen in a backward compatible way. And the last thing I would like to show you is what a real custom priming can look like. Just so you believe me when I say it's relatively powerful.
So what you showed us before with the tables, you couldn't apply that into the sales table and add an extra field already now?
You can do that now.
Yeah, okay.
Yeah. Yeah. You can't remove a field from the sales table.
Okay.
One of your fields you can remove. And I haven't put in things like app or partner ownership. So if advisor is out to smash the tables of Ganske Enkelt, this system will not protect him against that.
And you've not considered a scheme like Microsoft does with the base table and the extension table and something that combines them or something like that?
No. To me, that would add complexity without actually making it really very much better. So here we have an example of real-life priming code, which both reads things. So we check is this table physically present in the database? We execute a select, get something back from that. We set up an update and a delete. We do some magic, and then you see we do execute the delete, sending in the ID. This matches that one. We do a lot of verbose logging. Here we have an insert that comes from a select. So this database layer is not like NetServer's database layer. This is a database layer that passes stuff through, except for what's within curly braces. So it means you can say anything that's legal to say. But it's your responsibility to ensure it is actually legal, not just on SQL Server, but also on other databases you want to support. And for instance, you can't do an insert or an update from a join on Oracle. They just don't have that syntax. You can do subselects. How do you find out that? Well, the hard way. Yeah. No, we do not check it. Whatever you ask us to do here, we'll do it. And if it breaks, that's up to you to find. And you can see I was on the verge of doing this as part of the upgrade, and I thought, chicken or not. I'm not doing that. So these old dictionary tables will stick around for a while, but they are fossils. They are not used for anything. If you change them, it doesn't mean anything. If you use the old dictionary SDK on them to create stuff, the new database model is not going to know about it. When the upgrade runs, we do look at the dictionary tables. If we find partner tables in them, we take all the information we can and we update the database model so that the new 8.1 database model is aware of whatever partner-defined tables are already there. And we are testing all this on our own database, which, as you probably know, contains a lot of interesting stuff. We have extra tables, we have extra fields, we have partner tables, we have some fairly irregular tables, we have places where someone created an extra table, took it away, put in a view instead. Yeah.
And are there methods for getting the list of new tables, like you selected from the conceptual table, but what about the new model?
Yeah, the new model, the only thing you see in the database is in the sequence table. Because there you have the name and the table number of every table. So that's...
I won't be able to get an array or something like that.
No. If you want to look at the details, what the database model says about tables, then you have to actually write some code to call the read database model and then look at it in the debugger or dump it. You can use linkpad.
But like you did there, you queried the conceptual tables to see if you had some needs for special...
Yeah, but that is because this step is explicitly reverse engineering the conceptual table once during the upgrade to 8.1.
So we won't be able to do that
No.
anymore?
No, you will not. No. So that's the end of those dictionary tables. And I'm just a chicken, so I'm not deleting them. And it turned out to be a good idea because the code broke out of its sandbox and upgraded not our production database, but a copy of it we had installed, and it was a week before anyone noticed, which is, proves that the upgrade is not too destructive. Yes, Phil.
How does this fit in with the web services layer? Is it possible in the future for us to create new tables using the web services, like for online databases?
Probably yes, now no. So in the first release, I don't think we will be doing that. I'm not sure. It depends on the feedback you give us. But if and when we do it, and I'm pretty sure we will do it, you will be passing in those command objects, and the command objects look very much like the table model. The add table command object is property by property the same as a table model, except all the properties, or most of them, are nullable. Because if you modify a table, we use nullable properties to say, I don't have an opinion. I'm not modifying the length or anything. But this will come when it comes. Yes, Tony?
When it comes to the partner-defined tables to the agents, it's a great scenario where you put defined tables in there and have the ability to possibly pass in some priming data. But once it's in there, you don't have any way of actually changing the data that's in there. You don't have the APIs for accessing and modifying
Yeah.
the partner-defined table data. So we need to solve that problem first
Yeah.
before I think this makes sense.
Yeah.
All of this is very relevant, or extremely relevant to apps in the App Store.
Yes, I know.
We have to hack our data somewhere. Now it's maybe in the user preference.
User preference or foreign key.
Yeah.
Yes, I know. And like Tony said, we need to come up with a good and consistent story on partner-defined tables. How to create them, how to put stuff into them, how to take stuff out of them, how to protect the data against unwanted changes. And I'll be happy to take any feedback you have on good ways of doing that.
Another question, a small one, is will the dynamic archive provider understand these tables?
Oh, absolutely, because these tables are, by definition, ordinary tables. there's one bit that says a table is actually owned by SuperOffice in the model to prevent you from trashing it. But apart from that, table is a table, field is a field.
So CRM script.
CRM script will see these, definitely. And the structures in NetServer, SO table and SO field structures in NetServer are 90%, 99% the same. They are just initialized differently. They are initialized from this model instead of the old dictionary tables. Once initialized, those structures are the same. They have to be, because otherwise we would trigger a huge rewrite and huge instability. So we've actually done textual dumps of these structures and compared them before and after to make sure that the differences are only the ones we actually want to be there. So I can prove that this system is actually backwards compatible. And another good piece of evidence is we merged this from our functional branch into the main branch on Friday, and I haven't heard anything since. And there are people developing all the time. So I'm quite happy about that. I think, Tony, you are the timekeeper on this.
Next session starts in 7 minutes.
And I think, I'm not sure if I have the next session, and I'm not sure if it's in the same room. So, but I can two more questions, and then we have to go. Yes. Is it possible to define views? No, it's not. Just physical tables. No, they are not. And that's part of the story that we are missing. We don't have a path for partner-defined tables from the database through the database layer into the user interface. That story is as good or bad as it has always been. So we're not tackling that yet. One thing at a time. Okay, thank you very much for coming, and we'll hear more of this.